Welcome back to another video, and in this video we are going to be talking about how intervals work. Now, last video we talked about all about functions and everything like that, so the next step for us would be intervals. Now, what is like an interval, right? So an interval, we usually use that in mathematics to figure out, hey, from which point do we start at and which point do we end at, right? So we have a few different types of intervals here. So first off, we have a closed interval. Closed interval. Now, a closed interval is where both of the endpoints are inclusive. So they're included inside of whatever interval that we have. So how would we actually draw that out on a number line, right? So on a number line, let's say we're trying to go from 5 to 2, right? So we're going to have closed circles here, right? Hence why it's called the closed interval, and everything's inclusive, and then we just draw a line from this to here, right? So this is what we call a closed interval, right? So now you might ask, since this is a number line, we're not going to be using a number line everywhere, right? So how would we actually use this in notation form, right? So since we're going from 2 to 5, right? We can write it as, well, this isn't a really good number line because I have the larger number on the left and then the smaller number on the right. One way we can fix this is -5. There we go. Okay. So our interval is from -5 to 2. Okay, we're changing stuff on the spot. Now, in inequality form, right? Inequality form, it would be -5 is less than or equal to x and is less than or equal to 2. So this is what it means is that the x value could be equal to -5, but it ultimately has to be also larger than -5. It cannot be less than -5, and that's it, right? But for its upper bound, right, for its 2, it could be equal to 2, right? But it has to be less than 2 though. So it can't be, the x value can't be 3, the x value can't be -6, because those are not in the interval that we have. So now, what if I said that we have something called interval form, right? Now, interval form gets a little bit confusing here because we don't use it too much, but it's good to like write in shorthand, right? So we can say that x is an element of brackets -5, 2. Now, let's break this down, right? Let's break this down. So x in this case is our domain, right? It's telling us what is the interval containing, right? But it could also be like y is an element of, right? That means that we're trying to signify that, hey, it's the range instead of the domain, right? Now, this silly looking e, right? It just means is an element of, right? So it's like a symbol that we usually use whenever we're trying to find, hey, x is an element of, and whatever interval that we have. So now here, we use brackets, right? We're using brackets. We're not using parentheses or anything like that. This just means inclusive, right? This means inclusive. And then, of course, over here, you have your interval, right? Now, just because that this is closed circles, right? Closed circle. we have to use brackets. Use brackets. And then of course I'm going to use this, right? Those are what brackets are. Now, whenever you have an inclusive interval where everything's included, right? You have to use brackets. You do not use parentheses, you do not use any other thing that there is, right? So, continuing on to our next type of interval is called the open interval. Okay, so open interval here, right? So let's draw a number line again because it helps, right? We have -5 and to 2, right? Let's say that I have an open interval. Now, hence by the name, we're gonna draw two open circles, right? I should have done this in red. Two open circles here, right? And of course, a line connecting the two, right? Which signifies that the interval is between -5 and 2. So now, how would we do this in inequality form? Inequality form. So instead of using like less than or equal to or greater than or equal to, right? We can use just the greater than and the less than, right? So in this case, it would be -5 is less than x, and x is also less than 2, right? So now, the number that x withholds cannot be equal to any of the endpoints, and also it can't be past any of the endpoints. So it can't, in this case, it can't be larger than 2, it can't be smaller than -5, and also it cannot be equal to any of those numbers, right? So if x was equal to 0, then yes, it'll work. If x is equal to 2, that would not work because it's equal to 2, right? And in this case, we don't want it equal to 2. So how would we draw this? I mean, how would we write this in interval form? Interval form. Now, this is where it gets a little tricky, right? So we're gonna write the basics first. So we're gonna write the domain, which is just x is an element of, right? Now, previously, for a closed interval, we used brackets, right? We use a straight brackets. But for any open interval, we're gonna use parentheses, all right? So we're gonna draw parentheses, and then -5, comma, 2, close parentheses. Now, this is the thing here. So whenever you're doing these interval form, right, you must remember that the brackets and the parentheses matter. So if for whatever reason you write the wrong parentheses and brackets, right, it's a whole different meaning, right? So let's say in this case, if you just did the straight brackets, it means that it's inclusive. But as an open interval, this is exclusive, right? So it's not included inside of it. So you want to make sure that you don't make that kind of error there. And I'll tell you one thing, a lot of students make that error at the beginning. It's because it's something new to them and they haven't got adjusted yet. So now for our next type, right, is just a half open interval. Now for a half open interval, right, it's quite simple. Hence by the name, let's say we have -5 to 2 again, right? Let's say that -5 is a closed circle, right? But then 2 is an open circle, right? And then we have this, a line connecting the 2, right? Now, by looking at that, right, what do you think the inequality would be? Now, by looking at -5, it's a closed circle here, right? So we're gonna write closed. And then at 2, it's gonna be open, right? So since it's closed at -5, we can say that it would be, you can also equal that number, right? So we're gonna write -5 is going to be less than or equal to x, right? And then over here, since 2 is an open circle, so the x value cannot equal to 2, so we can only write less. X is less than 2, right? And that's how simple it is, right? Now, what if we write it in interval form, right? So interval form in here, we can say x is an element of, right? X is an element of, now here's where we gotta be careful. So since -5 is a closed circle, we're gonna use straight brackets of -5, right? Now, comma, 2 is an open circle, so we're gonna have to use parentheses at the end. So we're gonna just write 2 parentheses. That's how simple it is. Remember, straight brackets for anything that's inclusive or anything that's closed, and then parentheses for anything that's open. Now, we do have some special cases here where our special cases include infinity, right? So before we continue on to infinity, let's do some practice first, right? So I'm gonna draw you a line, a number line, maybe a better number line here, right? And then we're gonna label this closed circle at -3, and then an open circle at 25. So now for A, write the inequality for this. Inequality. And then for B, write the interval. So take a moment and figure that out for yourselves. Alright, hopefully you just took a look at it and you might have seen one that missing. I'm missing how it's connected, right? So if you assume that this is connected like this, then you're on the right track. Alright, so there you go. It's a little bit better now. Alright, so let's try to solve this together. How about that? So inequality form, we're gonna have to use the same example that we used up here where with the half open interval, right? So by taking a look at the half open interval, I mean the half open inequality, right? So since -3 is closed, so we're gonna write -3 is less than or equal to x. And since 25 is open, we only need to write is x is less than 25 because 25 is not inclusive, but then -3 is inclusive. So now how would we write this in interval form, right? So now we can write x is an element of, and then close brackets, well, the straight brackets, right? -3, comma, 25, but this time we're going to use the parentheses at the end as well, right? So it's generally around this kind of basis topic. So as long as you figured this out, then you should be good. Now, leading up to our special case, which is infinity, right? Now, infinity, it works a little bit differently, but not too entirely different. We do have a few rules, right? So, infinity interval. So, we have our number line here. Let's say this is 5, right? So, close interval at 5. And we're going to shoot it all the way up to positive infinity, right? So how would we write the interval for this, right? So let's take a look at its inequality first. So it's inequality. Now, we're trying to say that x is larger, well, x is any value between 5 and positive infinity, right? So we can say that x is greater than or equal to 5, right? The whole reason why we just did that and we didn't include the positive infinity because x is greater than or equal to 5 already tells you a lot, right? So based on that equation, based on that inequality, we can tell that, hey, all the x values that we have has to be greater than or equal to 5. So it could be positive infinity, it could be 1,000, it could be 2,000, right? It could be 1,000,000, 1,000,000,000, right? So now let's see if we can figure out what the interval form would be. Now, we're going to write the same thing. X is an element of, right? And in this case, since 5 is a closed circle, then we can just write the brackets, right? The straight brackets of 5, comma, we have positive infinity, right? So something as good practice that I do is I always write the positive in front of the infinity sign, right? So if it was negative infinity, yes, you would write negative infinity. But if it was positive infinity, what I do is that I always write positive infinity because you always want to double check that, hey, it's positive. But we are missing one thing. We're missing the last operator here. Is it a parentheses or is it a bracket? Now, some people would say it's a bracket, right? But we can't physically determine how large positive infinity goes to. So the only thing that we can use is parentheses, right? So here we make a new rule, right? Whenever writing interval for any side of infinity, parentheses must be used. Only on the infinity side. So that's our new rule here. So let's say, because in this case 5 is a closed circle, right? We can't put parentheses on the 5 because we still want to say that, hey, 5 can, the x value can also equal 5, right? So we can only put the parentheses on the positive infinity here. If it was negative infinity, it would be the same, yes. So take a look at this problem and try it out. And to your knowledge, that is a open circle. That is open circle. Now find the inequality for this. And then B, find the interval. Hopefully you just looked at it and tried to figure this out. And our inequality, right? 5 is basically just the larger number, right? But the x value cannot equal 5 since it's an open circle. So we're going to write negative infinity first because that's a smaller number, right? And that has to be less than 5, right? It won't be less than or equal to, right? Because it's an open circle. So now for the interval, x is an element of, right? X is an element of this time. Remember how like we said that whenever we have infinity, we're going to use the parentheses on that infinity, right? We're going to use parentheses, negative infinity, comma. The upper limit, the bound is just 5, but it's an open circle, so we're going to also have to use parentheses on it as well. And that is our answer, folks. That is one of the easiest notations that you can do. But once you move on to like function with interval notation, then it gets a little bit uh, complicated, and you know it's going to be in the same type of scenario here, especially when you get to like domain and range and all that stuff. So make sure you guys practice on these problems, right? Find all the resources you can, because this is one of the topics that many students don't really understand that well just because of how it works. So make sure you guys keep on practicing, and I will see you guys in the next video.